In this video, you're going to see both snapshots and live action of the Ampaire Cessna Skymaster. And what you are observing is a flying experimental test bed that ARPA-E owns and Ampaire operates. Ampaire is a company in Los Angeles that is hybridizing aircraft. In this particular case, the Skymaster has two engines, a front and a rear. And as you can see in the snapshots, the front engine and the rear engine counter-rotate, so they work together to propel the aircraft. In their hybridization, they're taking the rear engine out and replacing that with an electric drive so that they have a hybrid electric aircraft. You can see the logos on the side of the plane there, the University of Arkansas and the UA Power Group, ARPA-E and Ampaire. And as the video begins to roll here, we'll see the pilot start to get into the plane. And what he's going to do is he's going to fire up the electric engine in the back, and then he'll fire up the gas engine in the front and taxi it out to the runway in a moment. This project was undertaken by the University of Arkansas and also with the organizations, University of Illinois at Urbana-Champaign, Wolfspeed, and of course Ampaire as the system integrator. ARPA-E was the funding agency under the Circuits program. And in this particular video, what you're going to see is a flight around the airfield in Camarillo, California on February 20th, which was the first flight of this particular motor drive designed and developed by this team. The motor drive is an all silicon carbide motor drive rated at about 250 kilowatts. It includes Wolfspeed modules that were mounted inside the motor drive, and modules that also included silicon carbide gate drivers and a hybrid 3D printed and metal cold plate for thermal management. So this thing boasts a gravimetric density of 30 kilowatts per kilogram. So it's very lightweight, has a very good power to weight ratio, and really in this particular application only 160 kilowatts is typically required at full power. You can see the pilot has fired up both engines here in the video and is getting ready to taxi out to the runway to take off. Now, typically speaking, the user scenario or the flight mission profile would go something like this in a fully functional hybrid aircraft. While you're under taxi, you would be propelling mostly with electric, in fact all electric. Since this is an experimental aircraft, however, the front engine needs to be running for safety as a backup in case of some sort of failure. This plane will fly on one engine alone. So during the taxi, under electric. Then as we proceed to take off, again under electric power primarily. Now this particular aircraft is running off of an 800-volt battery. The 800-volt battery is driving the energy into the power electronics that we developed, the motor drive, and then we're driving a axial flux motor that's turning the propeller. So there is no gearing involved here. This is all controlled by the power electronics. As you can see, the plane is about to take off here, and as it accelerates up and starts to lift off there at the airport, then you'll start to see the surrounding landscape. And in this particular scenario, once it's at cruise, this is typically when it would run mostly off of the gas engine to recharge the batteries if they chose to do so, or they could continue to run off of electric and recharge once they get back into the hangar. And then once you're in, so you've got the taxi, the takeoff, the cruise, then the landing. Landing would be under sort of both sets of power if necessary. It wouldn't really matter. It's sort of gliding in. And then once you're in taxi again, you would be under electric power. So you can see in this particular video how they're circling the airfield. Now remember, this is the first university-based team to put this type of motor drive, or any type of motor drive that's FAA qualified, into a hybrid electric aircraft. Certainly that we're aware of, but we believe it's the first. ARPA-E believes it's the first, as you can see in the validations. So fast forwarding a bit, you can see they're starting to deploy the landing gear, and they're coming in for a landing again. Just a quick trip, roughly a 10-minute trip around the airfield, which we've shortened for this video. Bring this in for a landing and taxi on in. And so other features that we want to boast is the fact that the team developed the necessary communications, the functional hazards analysis that was required for FAA qualification, shock and vibration testing, and so forth that comes with that. So all of these things were done in a fashion that allowed this experiment and this flight to occur in the first place. And so now that they've landed and they're starting to taxi their way in, you'll see that eventually the front engine will be shut off. It appeared that the rear engine was, but that was just a resonance. So you can see the rear engine still going, and just about here, I think he'll shut off the front engine and he'll continue his taxiway, because at this point he no longer needs the safety of the gas engine. And so now he can just taxi in on electric power. And so as we're nearing the end of the video here, you can see from the tail wing, and then also on the right wing, a good look at the plane overall. And Ampaire this is their business, where they're retrofitting these planes as well as making other planes. There's other small craft that they're making hybrid as well. So here's the excited pilot showing us that he's jazzed about the whole thing, and he's certainly sharing our excitement as a result of this. So with that, I'll just conclude by thanking all the partners in the program: ARPA-E, Ampaire, University of Illinois Urbana-Champaign, Wolfspeed, and the University of Arkansas, and my teammates here.